Imagine standing next to a ship so large that it carries more than 6,000 passengers, thousands of crew members, restaurants, swimming pools, shopping malls, theaters, even entire parks. In fact, some modern cruise ships are longer than 3 football fields and taller than many skyscrapers. When people see these floating giants for the first time, they all ask the same question: how can something this enormous stay on the water? It weighs more than 200,000 tons. Almost entirely of steel, a material that sinks immediately if you throw a small piece into the sea. So why doesn't a cruise ship sink, and what happens if thousands of tons of water suddenly enter the ship? Can it survive giant waves, powerful storms, or even a collision? The answers are hidden inside one of the greatest engineering achievements ever created. Modern cruise ships are not just giant boats, they are floating cities built with incredible science, advanced engineering, and multiple layers of safety. Today, we're going deep inside these engineering marvels to discover why cruise ships almost never sink and how they safely carry millions of people across the oceans every year. To understand why a cruise ship floats, we first need to answer a simple question: why does a small piece of steel sink, but a giant steel ship stays on the surface? At first, it seems impossible. After all, cruise ships are built mostly from steel. And steel is much heavier than water. The secret is not the material, it's the design. A cruise ship is not a solid block of steel inside. Most of its structure is actually empty space. Those huge cabins, long hallways, restaurants, storage rooms, and massive engine compartments all contain air. That trapped air makes a huge difference. When engineers calculate the weight of a ship, they don't just look at the steel, they look at the entire structure, including all the air inside it. As a result, the ship's average density becomes lower than the density of water, and that's exactly what allows it to float. Imagine placing an empty metal bowl in a sink. The bowl floats. Now crush that same bowl into a tight ball, it immediately sinks. The material hasn't changed, only its shape. A cruise ship works in exactly the same way. Its enormous hull spreads the weight across a very large volume. As it enters the water, it pushes millions of liters of water aside. That displaced water pushes back upward, creating a powerful upward force, strong enough to support an entire floating city. This simple idea, discovered more than 2,000 years ago, still protects the largest cruise ships on Earth today. But floating is only the beginning. A cruise ship must also remain stable. Imagine thousands of passengers walking to one side of the ship, strong ocean waves hitting from the side, or powerful winds pushing against its massive structure. Why doesn't the ship simply tip over? The answer lies deep below the waterline. Although the upper decks look enormous, most of the ship's heavy equipment is installed as low as possible. The engines, generators, fuel tanks, fresh water tanks, and heavy machinery are all placed near the bottom of the ship. This creates a very low center of gravity, just like a racing car stays stable because most of its weight is close to the ground. Cruise ships use the same principle. But engineers don't stop there. Hidden beneath the hull are special ballast tanks. These giant tanks can be filled or emptied with seawater. By carefully adjusting the amount of water inside different tanks, the ship stays balanced even if passenger weight changes or weather conditions become difficult. Modern cruise ships also use powerful stabilizer fins. These wing-like structures extend from both sides below the water as the ship begins to roll. Computers automatically adjust the fins, reducing the movement before passengers can even notice it. That's why, even on rough seas, people inside can continue eating dinner, watching shows, or sleeping peacefully while outside. The ocean may be anything but calm. Now let's answer one of the biggest fears most people have. What happens if water starts entering the ship? Would it sink immediately? The answer is no. Modern cruise ships are designed to survive. Even if part of the ship is flooded inside the hull, the ship is divided into many watertight compartments. Think of them as giant sealed boxes, each one separated by strong steel walls and watertight doors. If the outer hull is damaged and water enters, it can only flood the affected compartment. The remaining sections stay completely sealed. This prevents the entire ship from filling with water. Powerful pumps immediately begin removing water From the damaged area at the same time, the ship's computers monitor every compartment, checking water levels, pressure, and the ship's balance if needed. Engineers can adjust the ballast tanks to keep the ship stable. This safety system exists because the maritime industry learned valuable lessons from past disasters. After the sinking of Titanic, ship design changed forever. Today's cruise ships must meet strict international safety standards. They are built with multiple backup systems so that one accident does not become a complete disaster. That's why modern cruise ships are among the safest forms of transportation in the world. But surviving a damaged hull is only one challenge. The real test comes from nature. The open ocean can produce waves higher than a 5-story building. Storm force winds can reach more than 150 kilometers per hour. So how can a giant cruise ship continue sailing through such extreme conditions? The answer begins long before the ship ever leaves the port. Every modern cruise ship is designed using advanced computer simulations. Engineers test thousands of virtual storms, powerful waves, hurricane-force winds, and extreme ocean conditions before the first piece of steel is even cut. Once the ship is built, it undergoes sea trials. These are real-world tests where engineers push the ship to its limits. They check steering, braking, engine performance, emergency systems, and stability in rough water. During normal voyages, the ship is constantly monitored. Weather satellites, radar systems, and advanced forecasting tools track storms hundreds of kilometers away. If dangerous weather is expected, the captain simply changes course. Instead of fighting the storm, the ship avoids it. That is why, despite their enormous size, modern cruise ships rarely face the most dangerous parts of the ocean. It's not just their strength that keeps passengers safe. It's smart planning, powerful technology, and decisions made long before the first wave arrives. Even with all these safety systems, no machine is completely risk-free. So what happens? The worst-case scenario actually occurs. A cruise ship carries enough lifeboats for every passenger and every crew member. In fact, international safety rules require ships to have even more capacity than the total number of people. Onboard crew members regularly practice emergency drills. They train to guide passengers, launch lifeboats, fight fires, and respond to almost every emergency imaginable inside the ship. Thousands of sensors work around the clock. They detect smoke, fire, flooding, engine problems, electrical faults, and even the opening of watertight doors. If any system detects danger, the bridge is alerted within seconds. Meanwhile, the engine room has multiple backup systems. Emergency generators can restore essential power even if the main electrical system fails. Navigation equipment, communication systems, emergency lighting, and critical safety equipment continue operating. Modern cruise ships are designed one goal above all else: not just to survive an emergency, but to give everyone on board enough time to respond safely. That is why millions of people travel across the world's oceans every year with an extraordinary level of safety and confidence. So why don't cruise ships sunk? This answer is not one invention. It's thousands of engineering decisions working together. A carefully designed hull, the science of buoyancy, a low center of gravity, ballast tanks, stabilizer fins, watertight compartments, powerful pumps, advanced weather forecasting, backup power systems, and one of the most highly trained crews in the transportation industry. Every voyage is supported by decades of research, millions of engineering hours, and lessons learned from history. The next time you see a giant cruise ship crossing the ocean, remember this: you're not just looking at a ship, you're looking at a floating city, a masterpiece of modern engineering built to carry thousands of lives safely across some of the world's most challenging waters. If you enjoyed this documentary, don't forget to like, share, and subscribe to RailForge, because here we uncover the incredible engineering behind the world's greatest machines, mega structures, and technological wonders. Thanks for watching, and we'll see you in the next documentary.